In this video, we reveal the web of deception surrounding our understanding of the cosmos. Today, you will learn why the sun is not yellow, why Mercury is not the hottest planet, why planets do not orbit the sun. Can you fly through an asteroid belt? Why is the sun hot, but not burning? Get ready to have your worldview shattered in this captivating expose of cosmic deception. The sun is yellow. If you've always believed that our sun is a bright yellow ball of fire, that understanding is not entirely accurate. Contrary to popular belief, the sun is not yellow, but rather emits light that appears greenish in color. Scientists determine a star's temperature based on the color spectrum it emits, with cooler stars appearing more red and the hottest stars appearing blue. The sun emits a significant amount of energy at a wavelength close to green. However, because it also emits other wavelengths, these colors blend together, resulting in a vibrant mixture that appears white to our eyes. This phenomenon can be observed when looking at the sun from the International Space Station. On Earth, the sun appears yellow due to our atmosphere's ability to scatter blue light effectively. As a result, the blue wavelengths are scattered away and the remaining colors combine, giving the sun a yellow appearance. If our sun were actually yellow, it would be around 800 degrees Celsius cooler. Consequently, our solar system's habitable zone would shrink and Earth would become a frozen and lifeless planet. However, the color of the sun is not the only misconception you might have had. There are likely other aspects of space that have been misrepresented or misunderstood. The sun is on fire. While the sun is incredibly hot, it is not on fire in the traditional sense. The concept of burning involves a chemical reaction between oxygen and fuel. However, the sun is predominantly composed of hydrogen and helium gases with minimal amounts of oxygen. The sun operates as a massive nuclear reactor through a process called nuclear fusion. In its core, hydrogen atoms undergo fusion to form helium, releasing an immense amount of energy in the process. This energy is what makes the sun scorching hot and enables it to emit light and heat. Explosions in space. In the vacuum of space where there is no air or atmosphere, traditional combustion reactions like fire cannot occur. Fire requires oxygen to sustain the chemical reaction. Since space is devoid of oxygen, there won't be any flames or explosions like what we see in movies, such as Star Wars. You can't count the stars. While it may appear that there are countless stars in the night sky, astronomers have made efforts to catalog and quantify them. The Yale Bright Star Catalog is one such compilation that lists 9,110 stars visible to the naked eye from Earth. Try to count them all for yourself. You can't fly through an asteroid belt. The portrayal of asteroid belts in movies can often be misleading. In reality, the asteroid belt located between Mars and Jupiter is not a densely packed obstacle course. While it contains trillions of space rocks that vary in size, ranging from tiny particles to ones as large as a quarter of the moon, they are spread out over a vast distance. The asteroid belt spans about 225 million kilometers, which is roughly 1.5 times the distance between the Earth and the Sun. As a result, the space rocks within the belt are distributed millions of kilometers apart from one another. This significant spacing makes it highly unlikely for a spacecraft to collide with an asteroid while passing through the belt. You instantly freeze in space. If you were expelled from the airlock and exposed to the immense expanse of space, you wouldn't instantaneously become frozen solid like a popsicle. This is because freezing requires the transfer of heat from space to your body. However, in the vacuum of space, heat or cold doesn't propagate quickly. Although your body would eventually freeze, it would take hours for that to occur. By that time, you would have already succumbed to another cause of death. You explode in space. In the vacuum of space, you wouldn't experience an explosive decompression. However, your body would indeed undergo inflation. The nitrogen present in your bloodstream would form bubbles, causing you to swell up to twice your normal size. Nevertheless, it is not the inflation that would be fatal. The absence of oxygen is the primary concern. Within approximately 15 seconds of being in space, your brain would not receive enough oxygen from your blood, resulting in loss of consciousness. Subsequently, your other organs would gradually shut down, Thus, the outcome would be game over. Space is cold. Space may seem extremely cold, but in reality, it doesn't possess a temperature. Temperature is determined by the speed and energy of particles. In the true vacuum of space, there are no particles present to move around, resulting in the absence of temperature. However, outer space is not a perfect vacuum. It contains particles and radiation that can generate heat. Certain regions of space, particularly those near stars, can be quite hot. However, as you move farther away from stars, the particles become more dispersed, leading to colder temperatures in those areas. Some dense gas clouds, for example, can reach extremely low temperatures, as cold as -263 degrees Celsius. Mercury is the hottest planet. While Mercury is the closest planet to the Sun, it may come as a surprise that it's not the hottest planet in our solar system. However, it is undoubtedly an extreme environment. During the day, the surface temperature of Mercury can soar up to 430 degrees Celsius. At night, it plummets to -180 degrees Celsius. Quite a drastic temperature range. On the other hand, the most infernal planet in our solar system is Venus. Unlike Mercury, which lacks a substantial atmosphere to retain solar heat, Venus has an incredibly thick atmosphere. This dense atmosphere creates a greenhouse effect, similar to an intensified form of global warming. As a result, Venus experiences scorching conditions with a surface temperature averaging around 475 degrees Celsius. It truly is a hot, hellish place in our celestial neighborhood. The solar system stays in place. Indeed, our solar system is not stationary within our galaxy, but is actually in motion. It is hurtling through space at a remarkable speed of 220 kilometers per second, which is 7 times faster than the orbital speed of Earth around the Sun. To complete one full orbit around the Milky Way, our solar system requires approximately 230 million years. To put that immense time frame into perspective, the last time our solar system occupied its current location in the Milky Way, Earth was part of a supercontinent known as Pangaea, and dinosaurs were beginning to emerge and roam the Earth. Planets orbit the Sun. In the solar system, all celestial objects, including planets and moons, are engaged in a gravitational interplay. Instead of a simplistic model where planets orbit around the Sun alone, the reality is more complex. Planets and the Sun actually orbit around a common point called the barycenter. The barycenter represents the balance of gravitational forces between the Sun and the planets. While for Earth, the barycenter is situated so close to the core of the Sun that the distinction is negligible. For massive planets like Jupiter, the barycenter can be significantly distant from the Sun's center, around 55,000 kilometers away. Consequently, in such cases, the gas giant and the Sun are indeed orbiting each other to some degree. Earth is a sphere. Although Earth appears round when seen from space, it is actually shaped like an oblate ellipsoid. This means it is slightly flattened at the poles and bulges at the equator. The bulge is a result of the centrifugal force caused by the Earth's rotation. Due to this bulge, Earth's equatorial diameter is approximately 43 kilometers, larger than its polar diameter. As a result, gravity at the equator is slightly weaker compared to the poles. This difference in gravity can have practical implications, such as making it slightly easier to launch spaceships from the equatorial regions. The additional rotational velocity at the equator provides a slight boost to the launch. There is no sound in space. The statement in space, "No one can hear you scream," is generally true. Because sound requires a medium to propagate. And in the vacuum of space, molecules are too spread out for sound waves to travel effectively. Therefore, most cosmic events, such as supernovas or colliding black holes, do not produce audible sounds that could be heard by an observer. However, there are specific regions in space where sound can travel due to the presence of dense particles or gases. One example is the hot gas cloud surrounding the black hole at the center of the Perseus galaxy cluster. This gas cloud is abundant enough to allow sound waves to propagate through it. In such cases, it is possible to detect and interpret the signals from these cosmic phenomena as sound. That's all for today. And as usual, pump your brains. Bye.